Ipsit, what do you understand by refraction of light?
Sir, refraction is basically when something
I have asked Ipsit the question. Let him answer, please.
when something changes medium,
Okay.
changes speed. For example,
Okay, wait. You have said when something changes medium,
direction.
when light travels from one medium to another medium, if there is a change in speed, and if light is at an oblique, it changes direction. So the change in direction of a wave. So suppose this is the incident wave. If it changes direction like this, instead of going straight, it changes direction. That is called refraction. Now, based on that concept, I am going to do a magic trick.
Yes, sir.
So you can see this beaker. Okay.
So what is that?
This is a beaker filled with castor oil. Okay. क्या बकवास कर रहे हैं? कहाँ पे oil beaker? Just oil. See. Okay. So now the magic which I am going to do is, I have a what do you call it? Mantra, a magic chant. If I tell that chant and put any object inside this beaker, it will grow bigger and bigger and bigger. And then when I take it out, it will come out in a bigger size. So if Kesha wants to go bigger, if I dip him in this beaker, bigger and bigger, and if I chant that mantra, he will become as big as Krishmi.
Sir, I know, sir, what is
Okay, first let me prove the power of my mantra. This tiny beaker is Kesha.
very easy, sir.
सर नहीं जाने सर मुझे प्लीज सर प्लीज
Sir, it's very easy.
I have already filled it with castor oil. So if I have to do the experiment on Kesha, you have to drink at least 2-3 liters of castor oil to fill your body with castor oil. And then I will immerse you in a pool of castor oil.
पूरी कश्मीर में आ गया बता नहीं सर
Agaram bagaram sola sulam am chu badam chu disappear ho jaatu. So now Keshav has completely disappeared. Now I am going to pull him back out and he will come like Krishmeet. Agaram bagaram sola sulam bada hoke bahar nikal.
सर यहीं पे ट्रिक खराब हो गया सर
ऊपर दिख रहा है मैं दूसरा नहीं
अच्छा केशव अंदर है उसके लिए बाहर से एक वो बड़ा वाला बॉडी आ जाएगा. Okay, so the small beaker became bigger one. अरे भाई आउटर बॉडी के अंदर इनर बॉडी है उसका, क्या करे? ठीक है, तो आप बताओ कैसे? How did he get on extra outer body like an exoskeleton? One at a time. Okay, let's listen to Krishna.
It was there inside the whole tank, but because we could see the same liquid in the bigger beaker and the smaller beaker,
Okay.
we could see the difference between we could see the beaker inside
मैं तो पार्टिकल का पूरा ट्रांसपेरेंसी
because the light traveled at the same speed.
Excellent. So the key thing is you had an outside beaker. It was filled with oil. So let us, and then I put one beaker inside. So this glass, and this is also filled with oil. This is also filled with oil. Okay? All these materials have the same refractive index. Now I haven't explained to you what is refractive index. So for now we imagine that it's a property of a material which determines how fast light will travel in that medium. Okay? So now if the refractive index of this glass, the oil here, this glass, the oil here, if it's all the same, then light will travel at the same speed in all these medium. So if light is coming from this side and you are looking from this side, if this is your eye, if this is emitting some light, if this wall is emitting some light, if this light enters your eye, you will see that wall. Agreed? So when it passes through this wall, it doesn't change its speed in any way. So it continues in its. So the fact is, if there is a change in speed, then it will bend. If there is no change in speed, it's as if it's traveling in the same medium. Tejveer, sit straight. So if there is no change in speed, it won't bend. What are you doing with the bag on the table? Yeah. Sit down. Sit properly. So if there is no change in the medium property, the speed will not change. Agreed? So if the speed doesn't change, it will not bend. So it's continuing the same direction. Then here also there is no change in the refractive index, so no change in speed, so no bending. Again no bending. So it just enters your eye.
So what is passing through the wall of the container at that time there will be a little bit of bend.
So very good point. Excellent. So when it passes here, so suppose this light ray is at an angle. So now if this is the normal, it will bend away from the normal. So that's why the outer glass wall of the beaker, the glass wall of the outer beaker, that you can see. You can clearly see that. Listen, you can clearly see that I am holding a beaker in front of you, right? That's because of that. There is a refractive index difference between the glass and the air. Please, cooperate. So since there is a clear difference, there is a clear bending of light when it leaves the glass and enters the air. So that's why you can see the outside beaker clearly. But inside the beaker, everything has same refractive index, so you don't see any bending happening, so you don't detect it. What is your question?
So, but then what about the glass of the beaker that is there inside?
Both are identical glass, and the refractive index is identical with the oil, so light doesn't bend. That's why you couldn't see it inside. Yes.
So in the first part, when the light comes from the...
Don't shake the camera so much, hold it tightly.
So in the first part, when the light comes from the air, won't it bend then?
That time it will bend. That's why you can see the beaker completely. Inner wall, back side and front side. You can see the 3D beaker. You can see it, right? When it's filled with oil. You can see that till here there is a beaker, and from outside this there is no beaker. You can see the boundary of the beaker from all sides. That's why. But inside that, if I put a glass...
So, but won't the oil have different refractive index than the glass?
Oil and glass are same. This particular oil is special. It's castor oil. It appears to have refractive index very close to that of this is borosilicon. Okay? Understood? So the ideal way to do this magic is that I will take some pieces of glass, I'll break them in front of you, and I'll put those pieces in this beaker. And then I'll say my magic mantra will make the broken pieces fuse into the beaker, into a new beaker. And then I'll pull out the existing beaker from inside. That is the ideal way, but it doesn't work out the way. In YouTube it works out very well. In real life, you can see the broken pieces. Because the refractive index has to be perfectly equal. Then they will disappear. Otherwise the edges of the broken pieces start appearing. Are you getting it? So with this, the best effect was only by immersing a beaker. If I put a broken piece. Okay, I'll tell you. Let's understand it. So you need to understand more detailed refractive index. So let's do that. You have a doubt, Tejveer?
Yes, sir, I have a doubt.
So where it will work?
Yeah.
Where it turners?
Second last.
Internals are on 16th.
What's coming, sir?
B form you don't have any exam. It's just workbook completion. So on 16th, workbook and textbook questions.
So you didn't ask us to...
I don't have to ask you. I'm sorry. You have been told on very first class that as you do the topics in class, the corresponding questions in the textbook and workbook have to be done by you.
Sir, I cannot have excuse
No, I
writing.
don't have to tell you. Do I ask you to eat daily? Do I ask you to drink water daily? Every day I will not tell you to do the homework.
Question.
What?
So when light enters the...
See, once it enters this outer glass, everything till it exits from here has same refractive index. So there is no more bending happening.
So it bends when it enters there.
Yes, it bends at the entry and it bends at the exit. Okay, now let's understand what is refractive index in more detail. Please take notes now. You can bring the stand here. They just
Yes.
bring the stand here so that the board is clearly.
So, but it'll block the view of the.
Okay, then from here the board is visible.
If the refractive index of the oil and the glass were different, how would it be so like?
Then you can clearly see the inner beaker and outer beaker. Because bending will happen at each transition.
लाइट जाएगा यहाँ से बेंड होगा फिर अंदर वाले ग्लास पे भी बेंड होगा ना.
So you will be able to see.
So how is bending going to?
You will realize it after we do a little more work.
Do you know any other rule that
Not from today's class, I haven't planned anything more. Now a little bit of math, let's do.
Okay, sir.
So refractive index. Please take these notes, I will check your notebook. When you leave the class, I will check and sign your notebook. So refractive index is also known as optical density. Okay? It is represented by the symbol N or mu.
So what's the refractive?
Refractive index is a property of a material which I am going to define. This symbol, this is M, this is OR,
You call it
OR.
N or U. Normally with that special.
This is small letter N in English, used for not, no, and this is Greek alphabet mu, M-U, mu. It's written like this and then like this. Understood? So different textbooks use either mu or N for refractive index.
That would say U call it.
Okay, now let us define it. So it is defined as the ratio of speed of light in vacuum, which is called small letter C. So speed of light in vacuum, what is it called, Anish? Small letter C. Divided by speed of light in medium.
So speed of light in vacuum is 3 into 10 to the power 8
Yes.
meters per second.
Okay, C by V. Okay, I wanted to tell you something. Here after every class when we do, we are supposed to cycle through 3 types of instruction, 3 types of pedagogy. Okay, so that is called fold, flex, and stretch. Okay. So if I forget, see what I need some help from you to implement this. So whenever anybody walks in to observe my lesson, they will be actually looking for how much time I am spending in each of these 3 zones: fold zone, flex zone, stretch zone. So you can visualize it like this. This is fold, this is flex, this is stretch. So I am supposed to go through these 3 stages repeatedly, like fold, flex, stretch. Fold, flex, stretch. So the idea is, when I start a new concept, which you don't know at all, so then obviously you are helpless, so you are fully dependent on me. So I have all your attention with me, that is fold. So I tell you everything, what to do, how to do, I will tell you all the new information. Okay? Then after I give you the new information, once you understand it, I should release the control a little bit to you, so that you do some work and I don't do all the work. So little bit of mental work you have to do in your notebooks. So I will give you some short questions, some easy questions, just to apply what I taught. That is flex. So if I give you a question and ask you to write it in your notebook, you should do. They will check whether you are all doing or not. If you are not doing, they will make a note that I gave an opportunity for flex, but it was ineffective. And then the next part is stretch. In flex you work independently, alone, okay? But in stretch you can discuss with your partners and answer a more tougher question. So after that I go to a new concept again, back to fold. So if I do like this, you won't get bored and the class will be more effective. You agree or not? Oops. Some flex. Sir, let's do some flex. And then remind me to let's do some stretch. I will also tell you which part we are doing right now as we transition. So the idea is we should have some time spent on each. Clear or not? So that will help me make the class more interesting for you.
Definitely.
So till now I was doing fold. I was telling you the concept, right?
Please.
So now I think it's time for some flex. So flex means
Please.
independent work. Okay, all of you tell me what is the refractive index of a medium, say glass.
1.8.
Refractive index of glass is how much I am going to ask you.
So,
Or wait, let me tell you in a
What's
different
the
way.
speed of light refraction?
Wait,
300,000.
let me say refractive index of glass is 1.5. Okay. And speed of light in vacuum is 3 into 10 to the power 8. So what is the speed of light in glass? Do it fast, quickly. Do it in your notebook individually.
so
This is
refractive.
flex.
So refractive index of glass isn't it 1.8?
I am giving you 1.5. It's typically 1.5. But there are variety of glasses. Nickel glass, chrome
So
glass.
what's the speed of light in medium?
I have asked you to find it out. I have told you that speed of light in vacuum is 3 into 10 to the power 8 meter per second. Refractive index of glass is 1.5. So what is the speed of light in that glass? It's a simple flex task. Because I have given the fold instruction, what is refractive index?
Sir,
Finished?
2 into 10 to the power 8. That's too clear. How much is the
Let the others also know. Okay, please don't scold anybody, it's all recording. You have to show how friendly, what a united class you are, supportive of each other.
Sir, we are very, very selfish.
Hmm? Okay, all of you finished?
Yes, sir.
Akhil finished?
Yes,
Sir,
sir.
I am bad.
Flex your mental muscle, come
Sir,
on.
I am bad at doing math.
Never say like that.
So,
Everybody is learning here. You can't be an expert from the beginning. You start as a novice and then you slowly you become an expert. So everybody takes time. Good. You can confirm your work.
Sir,
So speed of light in vacuum is 3 into 10 to the power. So the refractive index N is C by V. So this is 3 into 10 to the power 8 meter per second. This we have to find
2
out.
into 10.
This is 1.5. So V equals C by 1.5. 1.5 is 3 by 2. Agreed? Anything divided by 3 by 2 is multiplied by 2 by 3. Same as multiplied by 2 by 3. And the C is 3 into 10 to the power 8. So 3 cancels. So you get 2 into 10 to the power 8 meter per second.
I was right.
So in glass, light travels much slower than in vacuum.
So if you are it is proven.
No. You see the calculations?
No, I got it right.
1.5 is same as
सस्ते
3 by
मजे के
2.
लिए.
So 3 by 2 is equal to C by V. C is 3 into 10 to the power 8. So 3 and 3 will cancel. So V is 2 into 10 to the power 8. Clear? Satvik? Satvik clear? Clear? Okay, now. Oh.
Sir, C form की आदत नहीं
Yes,
गई.
and need for
Okay. So I have done some flex. Now let's move on to.
Stretching.
Let me see. Should we stretch?
So let's cool down and stretch.
Okay, now I will do a little more of folding now. Then after that I'll give you a stretching chance. See, I will explain something called as Snell's law of refraction. Snell's law of refraction. Okay.
इससे ज़्यादा नहीं हिलता.
So this law tells you
So do we do this?
by exactly how much angle the ray will refract when it travels from one medium to another medium of different refractive index. Okay? Not Snell, Snell.
So there is an experiment like this in a resource room, right?
Yeah. Okay, now listen.
So we can see that.
So what is
So
that
now-
called? So what is the proof?
This is the interface.
You know. So what is the proof behind the law?
Proof is by Huygens principle of secondary wavelengths. The way we did for diffraction,
Yes, sir, the compass one.
same way you can do it for this also. But we won't do it now. Guys, I can see many people still talking. Please avoid that. Between the two medium. Okay?
Yes, sir.
So let us say this is air and this is glass. Okay? So a medium which has a bigger value of refractive index. Okay, flex question for Ranjay. A medium which has a bigger value of refractive index. In that medium, light will travel faster or slower? Or just be quiet? So, wrong. Obviously, faster is wrong, it will be wrong, it will be slower only. Any medium, if refractive index is high, it means light travels slower in that because refractive index is C by V. So, if C is much bigger than V, the ratio will be a big number. You are dividing a big number by a small number, you will get a big number as the answer. What?
So what is R? Because R is the refer to the refractive index is RN.
Each person can call it by any name as long as you know what they are calling. Clear? Okay. So in this case, refractive index of glass is going to be bigger.
Sir, so the lesser the refractive index, the faster light the
Yes, in that medium. Yes. So refractive index of air is Na, refractive index of glass is Ng. Now we will use the name that 1 and 2. So which comes first, incident ray or refracted ray? Which comes first? Incident ray. So the medium which contains incident ray will be called as medium 1.
Medium 1.
Okay. So every parameter related to medium 1 will be denoted with 1 later. And the medium containing refracted ray will be called medium 2. So now refractive index of first medium will be called as N1. Refractive index of second medium will be called as N2. This is for in general. Whether I have air here, glass here, air here, I will just call N1 for the medium containing incident ray, N2 for the medium containing refracted ray. Clear till now? Yes or no?
Yes, sir.
Can I continue to fold or you need to stretch?
Sir, stretch.
Already got board of fold.
Fold, sir.
Let's finish this concept and then I will give you a chance.
Yes, sir.
So now, if I say this is the incident ray, let me draw an incident ray like this. In order to observe refraction, the incident ray should be at an oblique incidence. Agreed?
Yes, sir.
So if this is the normal, what do you call this angle of incidence? Oops, I told the answer in the question itself. So this angle will be called angle of incidence and we will give it a name theta1.
Theta. So what
Because
is the point of theta?
Please
Theta
subscribe
is the general name
and
for
the
angle.
video.
Theta is the general name for angle and I will give the suffix 1 to denote that it is the angle in the first medium. Angle which the light ray makes with the normal. This is the normal. Angle which the light ray makes with the normal in the first medium will be called theta1. It is our angle of incidence. So now, if this is the original direction, when it slows down, it will get towards the normal or away from the normal?
Towards.
When it slows down, yes. Correct, Ali? So in this it will slow down, so it will bend towards the normal.
So why does light bend
Absolutely.
towards
Good question. So why does light bend towards the normal while slowing down and away from the normal while speeding up is the next question I will answer. But I will answer it indirectly using an analogy. The correct answer can be understood by those Huygens principle of secondary wavelengths. But we won't waste time on that. You will learn it in 12th ISC course. Okay? In IB we don't explain that also. In 12th ISC it is explained properly. With compass you will draw secondary wavelengths and you will see for yourself that it actually bends.
Notes banaya hai.
Okay, towards the normal when it's going down and away from the normal when it's going up. But now we will understand that concept using an analogy. What?
So from rarer to denser.
What are you saying, yaar?
What's the normal, right? Rarer to denser towards normal, right?
Yes.
And from denser to rarer it's away from.
Yes. Slowing down towards the normal, speeding up away from the normal. Why? I will explain next. Okay. Now first let's understand what is Snell's law of refraction. So this is theta 2. So after I explain what is Snell's law of refraction, I will give you a chance to stretch. But Akhil, please. So this is the angle of Akhil. Flex question for you. Is this angle of incidence or refraction?
So,
Refraction. Okay? And since this is the angle in the second medium, it will be called theta 2. So now Snell's law of refraction statement is n1 sine of theta 1 is equal to n2 sine of theta 2.
what's this, sir?
This is the statement of Snell's law of refraction. Not statement, rather equation.
So sign.
So
Like the maths wala sign.
So if you know n1, if you know theta 1, if you know n2, you can solve for theta 2. That means if you know the angle of incidence, if you know the refractive index of both medium,
Oh.
you can predict what will be the angle of the refracted ray.
What's N1, sir?
N1 is refractive index of medium containing incident ray.
I got it.
So this formula tells you exactly how much it will bend. Are you getting it? Okay, now
Sir, don't erase it, please, sir.
tell me your name, I forgot.
Sir,
Aditya. Aditya will tell me what is the angle of refraction when light travels from air refractive index is 1 to glass whose refractive index is 1.5.
okay.
If the angle of incidence is 60 degrees.
So, what's sine 60?
You don't have calculator?
I don't have it right.
Okay, sine 60 is cos 30 which is root 3 by 2.
So,
Right, sir.
sir, it's N1 multiplied by sine 60 or
Okay, very good. N1 is 1.
1.
Okay, let's first write a substituted formula. N1 sin 60 equals.
N2 sign 2.
Yeah, tell me Aditya. N2
Theta 1 is 60, right?
Sine
sin
theta.
theta 2.
Theta.
Yeah, theta 1 is 60.
Yes, sir.
So N1 is
60.
1.
Into
Root 3 by 2
3 by 2
equals 1.5 is 3 by 2
Yes, sir.
sin theta 2.
Yes, sir.
So this 2 cancels.
Cancel, sir.
So sine of theta 2 equals root 3 by 3 which is 1 by root 3. So theta 2 is called as sine inverse of 1 by root 3. So in calculator, scientific calculator, you will have a button which has sine inverse
Shift
on it.
and sign.
Shift and sine function.
Yes, sir, we have.
So once you calculate 1 by root 3, you press shift and sine function and press this for this number, it will tell you the angle in degrees or radians, whatever is the mode of your calculator. You see, did you understand?
Sir, this was very fast.
Very good. So you stretched very well, Aditya. Good job. So now that you know how to apply this Snell's law formula, let's now see or get some insight into why light bends towards the normal if it slows down and away from the normal if it speeds up. Okay?
Yes, sir.
So we are going into fold again. Can you erase?